because of the comments I've been getting on 2 of my videos, how much does it cost to run your central heating pump and how to make your house warmer not colder this winter, I've decided to do a big experiment. Now, what I've decided to do is, I've got this heat only boiler here. Now I've chosen a heat only boiler because if it was a combi and somebody turns the tap on, then it's going to ruin the experiment. So on this experiment, it's only going to be the central heating. Now what I'm going to do is put a flow temperature of 75 degrees on this boiler, and then I'm going to run it for 4 hours. And I'm going to see how much gas it consumes and what temperature the ladies' toilets in the centre gets to. Now I've chosen the ladies' toilets because nobody's going to be going in and out, in and out, in and out, because there's no ladies here at the moment. Then I'm going to do a flow temperature of 55 degrees and do exactly the same thing. Run it for 4 hours, see how much gas it consumes and see how warm the ladies' toilets get. And then in a part 2 of this video, I'm going to be range rating this boiler and reducing the pump. So let's get on with it and find out exactly how much gas this will consume at 75 degrees flow temperature to how much it will do on 55. Now, just to make this clear, the radiator size is massively important for your flow temperature. Now, this radiator is actually been designed for a flow temperature of 80 degrees, not 75. So it's about 100 watts short of the requirements for the heat loss for this room. But that means for a flow temperature of 55 degrees, this radiator turns out to be about half the size that is required to heat this room. So I want you just to bear that in mind as you go through this video, that the size of the radiator is massively important for your flow temperature, because if your radiator is not big enough, then technically it ain't going to heat the room to what you want. Now today is Thursday the 2nd of Jan 2025, and as you can see from the chart, we're going to be getting an average of around 1 degree all day. Now this is the setup we've got. So we've got a meter. Stopwatch is going to time what's going on. I've got an analyzer set up for temperatures. So one's on the flow, one's on the return. Both reading around 10 degrees, as you can see. We've got a heat only boiler. I have disconnected the condensate and put a bowl there to see how much condensate we actually collect at the different temperatures. Now, why am I bothered actually showing you and collecting the condensate? Well, I suppose I better tell you how a condensing boiler works and why it's called a condensing boiler. Now, when you burn natural gas, you require oxygen and ignition source. But the byproducts of burning natural gas are carbon dioxide and water vapour. Yes, that's CO2 that everybody says is the death of this planet. And there was me thinking it was the building blocks of this planet. Anyway, let's not go there. So, how does this condensing boiler work and why is it called a condensing boiler? What happens is, there is a large heat exchanger in here to get as much heat out of the flue gases as it can. So this boiler burns 360 degrees around, or there are other boilers what burn downwards to try and get as much heat out of that flue temperature. So when the products of combustion exit the flue on this, on a non-condensing boiler, the flue temperature could be between 150 degrees centigrade and 200 degrees centigrade. But with a condensing boiler, the flue temperature is on an average of around about 50 degrees and slightly lower. Now, the lower we can get this flue temperature exiting this boiler, the more heat we've drawn out, which is called the latent heat. So the more latent heat we've used. So it makes the boiler more efficient. Now, a boiler will only condensate if the return temperature coming back into the boiler is lower than 55 degrees, because the water vapour has a dew point which is around 55 degrees, so it turns that water vapour from a vapour back into a liquid, and that's why it's called a condensing boiler, because the water vapour condenses on the heat exchanger because we've taken a lot of heat out of the flue temperature. So in a non-condensing boiler, because the flue products, the POCs, are so high in temperature, it will not condense. So in the old boilers, we didn't have to worry about the condensate. But in new boilers, because of this low temperature, we need to collect this acidic water and put it to drain. Now we're going to do a flow temperature of 75 degrees. That means our return temperature cannot go above 55 degrees. So we're asking a lot of the system to be able to take all the heat out of the radiators. So it would be sizing the heating system with a delta T of 20 degrees. So that's the difference between the flow and the return. That's going to be really hard. It's hard to get 10 degrees difference. But if you have a flow temperature of 55 degrees, that means the boiler will always be in condensing mode, because the return temperature will always be lower than 55 degrees. So that's why on the new building regs it says the flow temperatures, when we set up the boilers, have to have a flow temperature of 55 degrees, no more. But that means your radiators have to also be sized for a flow temperature of 55 degrees. Now, the lower the flue temperature exiting, the more heat we've taken out, the more efficient the boiler will be. So even with an exiting temperature of 55 degrees, there is still 55 degrees we can get out of that flue. So the better we size the radiators, we balance the central heating system, we use things like weather comp, we range rate the boilers, the more efficient this boiler will be, so the less gas it will use. So hopefully that's what we're going to prove in this video, that it's more efficient to run at 55 degrees than it is at 75 degrees. So shall we get on with it now? Then if we go in the ladies' toilets, I've got a thermometer set up on the radiator, which is reading 8.9 at the moment, and I've got a thermostat here, which is reading 9.5. Now this thermostat isn't operating the boiler, it's just telling us what the room temperature is. All the thermostatic radiator valves on all the radiators are set to maximum, and none of the radiators are balanced at the lock shield valves. This boiler is also running 8 radiators in total. The pump is going to be set on a fixed speed and not be modulating. Now let's get this boiler turned on, run it for an hour, and then we can check and see what results we've got after the first hour. Let's turn the boiler on. See what it reads. So it's saying the water temperature here is 9 degrees at the moment. Let's have a look and see what we're going to set this to. So 75, press tick. So the boiler now should fire up. We've got the pump running on speed 3. Burner's lit, and away the boiler goes. So with the 75 degrees centigrade flow temperature, our first meter reading is 00547.753. Now that's the first hour up. That's the meter reading. Got pump still on, speed 3, 44 watts. We've got a flow temperature of 72.1, return of 62.9, so 9.2 difference. On the front of the boiler, we make it light up, you can see the burner's still on and it's on 75 degrees. We've got a bit of water in the bottom of the bowl, so it has been condensating, not much though. Let's go and check the toilets out. So the radiator, on top of the radiator, it's reading 45.1, and the room temperature is reading 13.5. So that's the first hour. Let's see what the second hour brings us. That's hour number 2 up. That's the gas meter reading. We're still on speed 3, 44 watts. We're on a flow temperature of 72.6, return of 64.3, so an 8.3 difference. What's the boiler reading? So the boiler's still on 75 and it's still lit. How much condensate have we collected? A little bit more, it's dripping a little bit. Let's go and check out the temperatures in the toilet. So radiator's giving us 53.3 and the room temperature is 17. So that's hour 2. Let's give it another hour and see what happens in hour 3. So that's 3 hours up. That's the gas meter reading. Pump still on speed 3, 44 watts. We have flow temperature 72.7, return is 64.8, so 7.98 difference, keeps moving. Wake the boiler up, we've still got a flow temperature of 75, the burner is still lit. Have we got any more condensate? Not that much. There's a bit in there. Let's go to the toilet and check that out. So 49.3 on the radiator and 20 degrees in here. Now that's the end of hour 3. Let's check back for the final time in another hour. Right, that's the 4 hours up. That's the meter reading. The pump still on speed 3, 43 watts. Flow temperature 72.7, return 65, 7.7 difference. Wake the boiler up. We've still got a flow temperature of 75. The burner is still lit. Condensate. There's a little bit there. We'll find out exactly how much is in there later.
To the toilet.
46.1 on the red and 21 degrees in this toilet. So it's taken 4 hours to get to 21 degrees. So that's the 4 hours. So tomorrow we'll try it again, but with a flow temperature of 55 degrees instead of 75 degrees. Now I'm just going to collect this condensate, so we've got something to go off. I'm just going to stick it into this plastic tub because I haven't brought a measuring jug, but I'll put a line on how much it actually did get. So keep that on there for now. Here's how much condensate we actually did get, which is about half of this tub full. Now today on average is going to be about 1 degree warmer than yesterday, so that might make a little difference. Anyway, let's get on with it and see what today brings. So basically the same setup as yesterday. So that's the meter reading we've got at the moment. It is 10 degrees on the flow and return. Still collecting the condensate. We'll turn the boiler on in a minute. Let's go and check the temperature in the toilet. So, on the radiator, it says 11.1. And in the room, it says 10.5. So let's get the boiler turned on and start experiment day number 2 with a flow temperature of 55 degrees. Let's turn the boiler on. It says 10 degrees on the boiler. Let's set the temperature to 55. Let's do that. So now it should fire up. Pump's on number 3. So that's okay. We'll keep it on 3. Away the boiler goes. And let's start the stopwatch and take the reading. And we'll come back in an hour. So that's the first hour. That's the gas meter reading. We got 44 watts speed 3. We've got a flow temperature of 53.8, return of 47.8, a difference of 6 degrees. We've got a flow temperature of 55 degrees and the burner's on. This is how much condensate we've collected in the first hour. Let's go and check out the temperature in the ladies' toilets. We've got 36.3 on the rad, and the room temperature is 13 degrees. So that's after the first hour. Back in another hour. Two hours up. Gas meter reading. Pump still on 3, 44 watts. Got a flow temperature of 55.8, return 49.8. Well, difference 5.9 because that's changing. Boiler is flow temperature of 58, burner on. Not so much condensate we got. Let's go and check the temperature in the toilet. So 38.2 on the rad, and the room temperature 15.5. 2 hours. See you after 3. So that's 3 hours up. That's the gas meter reading. Still on the same on the pump. We've got a flow temperature of 56.8, return of 50.9, 5.9 difference. We've got a flow of 58. And let's have a look at the condensate. Does that look more than the last time? Anyway, let's go and check out the toilets. Radiator showing 39.3 and the room temperature 17.5. That's 3 hours down, 1 hour to go. Catch you in an hour. So 4 hours is up. Gas meter reading. Pump still on 44 watts. Flow temperature 57.6. Return 51.67. 5.9 degree difference. Boiler's on 59. Condensate water feels like there's a lot more, but we'll find out about that in a bit. Let's go and look at the temperature in the toilet. So, radiator 38.8, and the room temperature is 18.5. Now let's see if we collected more condensate with the lower flow temperature than we did with the higher one. Well, I think that's obvious we did, because I'm already way past the level. Still got quite a bit to get in. So this bottom line is the level of the water once we'd filled the tub to the top, and this was what was left over. We get more condensate on the flow temperature of 55 than we did from the flow temperature of 75. Now that's the end of the experiment. Let's get to the board and have a look at the results. So now you can see I've laid all the meter readings out on the board. This is the 75 degree flow side and this is the 55 degree. So after our first hour on the 75 degrees, we'd used 1.134 meters cubed an hour of gas. On the 55, we'd used 0.747 meters cubed of gas. Then second hour, we used 0.805 on the 75 and we used 0.529 on the 55. Then on 3 hours, 0.745 to 0.531. On 4 hours, 0.719 to 0.530. So in total, we used 3.403 meters cubed for the 75 degrees over the 4 hours. And on the 55, we used 2.327 meters cubed. So a difference of 1.066 meters cubed. So a load of you now will be going, oh, that was obvious. What a waste of time. I've wasted half an hour watching this video. But there are some interesting things that we can find from here. Obviously, when the boiler's initially starting up, it's going to use more gas. And I did not range rate this boiler. So if I'd range rated the boiler for the kilowatts what are required, these figures could even be lower. But one thing, they're slightly all over the place. See here on the how much we use in an hour, but here it's pretty consistent how much we used. And the biggest giveaway on how the boiler was working is how much condensate was being used. So at a 55 degree with the boiler condensing more, it will keep that heat exchanger nice and clear and nice and clean. Whereas on this one, there isn't that much cleaning out that heat exchanger. So it could cause problems in the future. So the boiler is running at a lot less heat. So it's not tiring itself out like it would do on the 75 degrees. What do you think about the figures? Put down in the comments what you think. I'm used to you all now, so just throw it at me. But anyway, let's now have a look at the temperatures. So here's the temperatures. Now, we did start off with a bit of a higher temperature on the 55 than we did with the 75 because the outside temperature was a little bit warmer, but the maximum after 4 hours it got to was 21.5 degrees. Now even the rad was just slightly undersized, but there is no room stat. This then would continue to go hotter and hotter and hotter if you weren't going to lose the heat. Now, on the 55, you can see consistency again, and we actually got up to 18.5 degrees, even though that radiator was half the size that is required to actually get to that room temperature of 21 degrees. So take from that what you like. Now in part 2, we're going to range rate the boiler down from 18 kilowatts to 10 kilowatts, and we're going to reduce the speed of the pump. Well, we're actually going to put it on the auto setting. And then we're going to collate all the information and find out whether it's cheaper or not to run your boiler at 55 degrees range rated than it is to run it at 75 degrees and not range rated. Anyway, hopefully you've liked the video, and I'll catch you on the next one. Cheers.